During preparation of wrought iron from cast iron, impurities are oxidized by. The given options are carbon dioxide, that is CO2, CO, MgO and Fe2O3. Class, first of all, we need to know that wrought iron is the purest form of carbon, which contains approximately 0.25 to 5% of carbon. Cast iron has impurities of carbon, sulfur, silicon and phosphorus. So class, impurities of cast iron are oxidized using hematite, which is Fe2O3, which acts as oxidizing agent and converts carbon into carbon monoxide. The reaction involved is Fe2O3 reacts with carbon to form iron and carbon monoxide. So hematite, that is Fe2O3, is the correct answer, which is used for the oxidation of impurities in cast iron. So class, let's move to our next question, which is question number 67. Let's read the question, class. Refining by liquation is based upon: first, difference in melting points of metals and impurities. Next, difference in boiling points of metal and impurities. Next is different in solubilities of metals and impurities in molten form. The last is difference in electrical conductivities of metal and impurities. Class, as we have already discussed liquation, it is a process of refining in which the melting point of impurities is higher than that of the metal. We can say that difference in melting point of metal and impurities must be there. So class, the correct answer is option number 1. Let's move to our next question, class, which is question number 68. Class, let's start the question. Reaction not involved in Serpek's method of concentration of bauxite ore is. Class, concentration of white bauxite is done by Serpek's method in the presence of coke and nitrogen gas. Class, Serpek's method involves 3 steps, which is Al2O3.2H2O reacts with N2 and carbon to give Aln, that is aluminium nitride, and carbon monoxide and water. The compound aluminium nitride further reacts with water to give aluminium hydroxide and ammonia. Aluminium hydroxide further decomposed to give Al2O3, that is alumina and water. The last step, which is alumina plus NaOH, gives meta-aluminate and water, does not involve in Serpek's method. So we can say that the correct answer is option number 4. Let's move to our next question, class, which is question number 69. Select the incorrect statement among the following. We are given with 4 options and we have to analyze which is the incorrect statement among the 4. The first is sulfur, silicon, phosphorus are oxidized and passed into the slag during smelting of iron. Yes, this is the correct statement. The next is in copper extraction, FeSiO3 is formed as slag. This is again correct, as copper pyrites has impurity Fes, which combines with SiO2 to form FeSiO3 slag. The next is germanium, gallium, indium are refined by zone refining. Yes, this is also correct. Zone refining is a process of refining used for semiconducting elements. The next is froth flotation process is generally used for the concentration of oxide ores. This is extremely wrong, as we all know that froth flotation is a process which is used for the concentration of sulfide ores rather than oxide ores. So class, the correct answer is option number 4. Let's move to our next question, class, which is question number 70. Let's read the question, class. Element having highest density at 298 Kelvin in the following is. The given options are nitrogen, phosphorus, arsenic and bismuth. So class, in this question we have to compare the density of group 15 elements. So let's see the density of given elements. Let's start with nitrogen, which has a density of 0.879 gram per centimeter cube. Next we have phosphorus, which has a density of 1.823 gram per centimeter cube. Next we have arsenic, which has a density of 5.778 gram per centimeter cube. Next we have bismuth, which has a density of 9.808 gram per centimeter cube. So we can easily analyze that down the group, the density of elements generally increases. So in the given options, bismuth has the highest density. So the correct answer is option number 4.